Hello everyone. Today myself Pranjal Verma, solution specialist in water and wastewater from Capricorn Technology, bring you to a weekly insight on how to compute a water age within our distribution network. Capricorn Technology is a Win-Zero company having a legacy of over 3 decades, has now become partner of choice for the AEC industries. Capricorn Technology is one of the biggest platinum partner of Autodesk and Bentley along with authorized training center. So today with over 10 offices across India and 220 inspired team member, we are serving over 20,000 customers in the building, infrastructure, manufacturing, along with a large number of other industries as well. So these are some of the features of computing water age, like how to create an alternative and how to set a calculation type to the age, and also how to create an age analysis scenario, and how we are going to create a color coding for identifying a water age of pipes. So basically, water age refers to the time it takes for water to travel from its source to consumer and is influenced by distribution system flow, velocity, and pipe length. So residence time in reservoir is probably the most important contributor to age. So it come in our mind that why model a water age? What is the benefit of it? Well, discussing about that, it helps us to give us an idea of the oldest area of water in the system, and it helps us size the proposed pipe, like is it too large or not. It also helps us to locate area where extra treatment may be needed. So we can say that many benefit is there. Similarly, in today's video, we will learn how Bentley WaterGEMS help you to create a water age for a random time period. So let's suppose this is my sample water distribution network and we have to create computing the water age within this network. So we will begin with running an age analysis for water in the system, assuming an initial age of 0 for all the node. So the water from the reservoir will be an infinite supply of new water. So the age of water elsewhere in the system will be reflection of time from the start of the run and how long ago the water left the reservoir. So the analysis will be run for a 2 week period, normally around for 336 hours. So based on this model size, 2 weeks should be more than adequate to capture the water age in the network. So firstly, what we have to do is we have to create an alternative for an age. So how to do this is go to analysis option. Under the alternative, this type of dialog box will be appear. Just expand the age alternative and create a new alternative as a base alternative. And now as we can see that the new alternative has been created. Now I'm just going to rename it as initial age equal to 0 and enter it. So as now we have created the alternative for an node as an initial age equal to 0. Now the next step would be as to create the scenario to assign the property. For that, go to the analysis under the scenario option. So this type of dialog box will be appear. Similarly, as we have created the alternative, here we will create a new child scenario. Just right click on the existing average day, go to the new option and create a child scenario. And I'm going to just rename it as age analysis. So now I have created a new scenario. Now what we have to do is we have to assign the property, because if we do not assign the property, the result would be not valid. So as we highlight this age analysis, we can see that on my right window there is a property for an age analysis. Just assign the property for the age. Here we can see as alternative option the age is there. Now click on this option on the drop down menu. So yeah, there is an initial age, just click on it. So I have assigned the property for an age. Now what we have to do is, I'm just closing this scenario. We have to give some of the input for the calculation of computing a water age. So for that, what we have to do is go to analysis option, then the option, just highlight the existing average day. So as we can see that the property for the same is been appeared on the right side of my window. Now I'm just going to suppose like the one thing is calculation type should be of age. So I'm just going to click on calculation type on this drop down menu and select an age. The next what we input have to give is like we have duration. So we are going to give the input as I told earlier for 336 hours for the 2 week. So I'm just entering the 336 hour for the duration. Yeah. So now all the input has been given necessary that we wanted our distribution network. Now what we have to do is just compute the result. I'm going to close this dialog box, going to the analysis option and compute it. It will take few seconds while calculating. Yeah, so this is how the calculation summary report has been generated. As we can see that after giving some relevant input, my balance is true for all the time hours for complete 336 hours. So this is how we can compute the water age. Now what we have to do is we have to do color coding to identify the water age pipe. For that what we have to do is on symbology option, right click on this pipe here, new and color coding. Set the field name as an age calculated and calculate joint is would be of full range and click this initialize button. Now apply and okay. So as we can see, so some there is changes in my within distribution network. So now what we have to do is we have to identify we have to create a legend. How to do that? Just right click on this age calculated. Here we can see that there is an option of an insert legend. Just click on it and click on that window. We can see the legend has been created. Now if we have to zoom, just scale it and zoom it according to your need. So this is how it has been shown. So this is how the legend has been created. Now we have to check within our distribution network according this color coding. What we have to do is go to analysis tab and time option, just play it. So I'm just forwarding it so that I can show you. Yeah. So as we can see that the pipe has been changed. So it's showing red and it's also showing shade. According to red, what is there? The value is 330.58.06. So similarly, this is how we can identify the age of the pipe. So next, what we have to do is if we have to see the graph of this particular water distribution network. So a good way to check if your network has had sufficient time to reach an equilibrium point is to look at age versus time graph for your element. So how we going to do that? Just click on this tank, right click on it and graph option. So here this type of dialog box will be appear for series option. Just go with the relevant option. The exiting average should be checked. Both the box should be checked. And here I'm just unchecking this hydraulic gate and I'm going to expand the result water quality and check was the age calculated as and okay. Yeah, so from this graph we can see that once a repeating pattern is reached, the age of water fluctuated between approximately 37 and 52 hours for complete one day. So this is how we can generate the graph also. So that's it for today. So for more videos and update, do subscribe our channel Capricorn Technology Private Limited and like and comment if you like the insight. We would be delighted to hear from you. So please reach out to us for any suggestion, query or topic you would want to discuss. See you next week. Thank you.